Alright. Number 5 and 7. All we gotta do, GCF. Alright? So, we're working on GCF first. So, what goes into 7, 47, and 30? Well, 1, right? Because 7 doesn't go into 30. So, bam. 7's prime. I know there's no GCF there. So, I move on. Now, I know that there's a star. In 2, there is a star variable, right? Because the star is that guy. Right there. Okay, so right away, I know that I have 2 parentheses and 7x and 7x. Okay? Third step, signs. That means this sign comes up. This sign tells me that these 2 signs are the same. Right? A sum means that they're the same. That means these 2 signs have to be what? Minus. Okay? Alright. Step 4. Product and sum. My product is 7 times 30, which is 21 and a 0. So 210. Right? My sum is the middle number, which is 47. Now I'm adding in the sum. And I'm multiplying to get 210s. I need 2 numbers that multiply to be 210, and they add to be 47. So what I like to do with a number like that's this large is break it down. 2, 1, 0, 5, 3. 3 goes into 10 3 times, or 2 times, 3 times, no, 2 times with 1 left.
No, it goes in
3 times with 1 left over, and then that's 5.
15.
And then 5 goes in 7, and 7 goes in 1. So I've got 2 times 3 times 5 times 7. I need to rearrange those numbers in a way that when I add them up, they add up to 2 numbers, they add up to be 47. Right? Let me show you. One way I can look at this is 5 times 7 and 2 times 3. Well, that would be 6, and that would be 5 times 7 is 35. Alright, so what do they add up to be? What's 35 plus 6? 41. Alright, not quite what I was looking for, right? Not quite what I was looking for. So I need something a little bit bigger than that. So maybe I take 2 times 3 times 5, right? And I add it to 7. So what is 2 times 3 times 5? So that would be 15 times 2, which is 30. That would be 37. So that's not going to work out for me. I could also take 2 times 3 times 7. What's 2 times 3 times 7? In other words, what's 6 times 7? 42. And 42 times, what's only left is 5, right? So 42 plus 7, 42 plus 5 is 47. So that's the one I want, right? This is the guy I want. 42 times 5. So 42 times 5 is going to be 42 plus 5, right? And they both are 47, right? So this is 47 and this is 210. Does that make sense? Okay? So it's 42 and 5. 42, it's big number first. Okay? Now, that's not going to get us back, right? That's not going to get us back to 7. Oops. Sorry about that. Is that 4x squared?
Mm-hmm.
That's not going to get us back to 7, because 7 times 7 is 49, right? I have an extra 7 in there. My star, right? My star is a 7. So I have a star cleanup. Okay? I have a star cleanup of 7. And the only factors of 7 are 7 and 1, right? So I got to pull 7 out of one of them and 1 out of the other. So which one of these does 7 go into both numbers? The first one or the second one? The first. So the first one, 7 goes into, and it goes in there x times and 6 times, right? And in the second one, a 1 goes into it, of course. 1 goes into everything, right? Just 7x minus 5. Okay, so we have our two factors. We have x minus 6, and we have 7x minus 5. So we were able to factor that first, the top part. Okay? Now we need to factor the bottom part. Again, starting with GCF. What goes into 4 and 24? 2. Okay.
4.
4. Okay. You notice that right afterwards, right?
Yeah.
Yeah. Because you're like in your head probably started dividing it and you're like, oh, they're both even. Right? That's fine. So, yeah, 4 goes into both of them. X squared and 6x, right? What goes into x squared and x? What? X. Yeah. Right? And it goes in there x times and 6 times, right? So this goes back to last week and the week before when we were working on that division part, right? When we were doing division, synthetic division. This is going to help us out. Okay, so I have 4x times x minus 6. You see anything that can cancel?
6.
X minus 6. Right? So we get 7x minus 5 over 4x. Now that's not the end though, right? Because this bottom, I can't let go to 0. Now if this is a number and this is 0, what's 0 times a number?
0.
Okay? So if this is 0, I'm screwed, right? It messes everything up because it blows up. Your equation goes to pot. It can't work. Okay? If you're building a bridge, right? And your variable you let become this amount, your bridge will fall down. Okay? It's one of the critical errors that creates a problem for your bridge. You just think of it like that. I can't maintain the bridge if I let that variable be this number. And in this case, the number is what?
0.
Yeah. So divide by 4, divide by 4, you get x cannot be 0. That's pretty simple. Okay? So I know that x cannot be 0. What else? What else can x not be? Remember, the whole thing can't go to 0. Even if you get rid of it, this is the most problem. This is the biggest problem people have in engineering. Is when they do a formula to figure out how they're going to construct this bridge, or some parabola, or a ship, or a spaceship, or a magnifying glass, or a magnifier, right, for something, okay, say for a telescope, okay, if they don't take into effect the variable, right, that they got rid of when they reduced the fraction, when they reduced the problem down to a simpler problem so they could deal with the simpler problem. This is the complex problem. But they reduce it down so they can just deal with it simply, right? It's easier to deal with this than it is with this, wouldn't you say? Right? So they'll reduce it down, but if they don't take into effect that x cannot be, x minus 6 cannot be 0, that means what? X cannot be 6. If they let their variable be 6, whatever they created is going to break. Okay? Whatever they created is going to break. So x cannot be 0 and it cannot be 6. Anything that's in the bottom cannot go to 0. Okay? Does that make sense? Now this next problem looks pretty easy. How many have figured out this next problem already? What is it? Not 0. 1. Right? Because it's 1. That's easy. It's 1, but what's the but? P cannot equal negative 16 over 10. How do I know it's negative 16 over 10? Because I know that it's always going to be the opposite of this divided by that. Right? When I set these problems up, because I've done them for 20 years now, actually probably more like 40, since I've done them since I was your age. Okay, 30. Plus 16, right? Cannot be 0, right? Then I just minus 16, right? So 10p cannot be negative 16, and then divide by 10. Okay, that's the long way. You know, but then I got to break it down, right? What goes into 16 and 10? 2. That goes in there 8 times. That goes into there, what, 5 times? So basically, can't be that, which is really negative 8 over 5, which is really negative 1 3/5. Right? So it's 1, whereas P cannot be negative 1 3/5. Okay? If you keep it as negative 16 over 10, I'm cool with that. Now, I don't know how your answers in the back of the book are. Oh, they're not showing you the reduction for some reason on 1 through which one is this? 0 and 6. So is this 7? 8/5. So they just reduced it to negative 8/5. Okay.